It arises due to the spatial orientation of ligands around the central metal atom or ion, right? I repeat again. It arises due to the spatial orientation of ligands around central metal atom or ion. It is called stereoisomers. It has two types. One is geometrical isomer. Another one is optical isomer. Right? The geometrical isomers we can apply in octahedral complex structure as well as square planar complex structure, right? So cis and trans, right? In octahedral complex structure, we can make a cis and a trans position and facial isomer, and then meridian isomer, right? In square planar complex, we can apply only cis and trans. We cannot find facial and meridian isomer, right? The first we will see octahedral complexes. The octahedral complexes, the metal will be center. Six ligands are present. So 1, then 2, 3, 4, 5, then 6, right? So in the octahedral complexes, so what are the cis position and the trans position we have to find it. Cis position and trans positions. So we can note that similar ligands are present in the same side means cis, opposite side means trans. For example, just look at this. The second and fourth are present opposite. These are trans, right? Now third and 5 present in the opposite. So trans position. 1 and 6 trans position. So for explaining this, just you assume the model here. First I write the trans position 1 and 6. So 1, 6. Then 2, 4. 2, 4. Then 3, 5. 3, 5. These three are trans position in octahedral complexes, right? Next, these three only opposite position, so trans. Adjacent position. So similar ligands are present in the adjacent position. For example, 1, 2, then 1, 3, 1, 2, 1, 3, then 1, 4, right? Then 1, 5, right? Now, so down also we can get it. 2, 6, then 3, 6, then 4, 6, then 5, 6, right? These are the positions are not opposite, These are adjacent side, right? Next, 2, 3, 2, 3, then 3, 4, 3, 4, 4, 5, next 2, 5, 2, 5. So totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 12 position or 6 position. 6 positions in the octahedral complexes. I repeat again. In the octahedral complex, first we have to find the opposite position alone. So remaining positions are 6 positions. Opposite positions are transposition. First we have to find the opposite positions. 1, 6 is opposite. 2, 4 is opposite. Then 3, 5 is opposite. Right? So 3 positions are opposite positions. The ligands are present in the opposite positions. So transposition. Right? Next, adjacent position. Similar groups are lying in the same side means cis isomer we can say. Adjacent position we see 1, 2, 1, 3, 1, 4, 1, 5. Right? Likewise 2, 6, 3, 6, 4, 6, 5, 6. Right? Then 2, 3, 3, 4, 4, 5, 2, 5. Right? So we have a 12 cis position and 3 transposition. Right? Next, facial isomer. Facial isomer and meridian isomer. How can we find it? So first we see facial isomer. Facial isomer. The central metal atom is cobalt, right? 3 plus. The octahedral complexes. Here, the facial isomer means 3 similar ligands. 3 similar ligands are present. The corner of triangular face, right? That is called facial isomer. Triangular face. 3 similar ligands are present the corner, right? Corner of triangular face of octahedral. That is called facial isomer. Right? Now, meridional isomer. Meridional isomer. So we can say mer isomer or meridional isomer. Meridional isomer, how will be? Cobalt is a central metal atom, right? Here, the 3 cyanide similar ligands are present, right? Around the meridian, right? Which an imaginary semicircle, right? Around the central metal atom. We can say the apex, the meridian, is taken as an imaginary to the opposite apex. Semicircle to the opposite apex. It is called meridional isomer. So the octagonal geometry, transposition we can find it, and 12 cis position also we can find it. Then facial isomer how will be, and meridional isomer how will be, right? So now the square planar complex. Square planar complex, how can we find? In the square planar complex, how can we find cis and trans isomer? Cis and trans isomer. This one octahedral. Just now we have finished. Now we are going to say square planar complex. The platinum, so central metal atom, right? The similar groups. Similar groups. So I use chlorine, chlorido. The ligand name is chlorido, right? So another two ligands, amine, right? The similar groups lie on the same side, so cis isomer. Now the trans isomer will be platinum. The similar groups lie on the opposite side, trans isomer, right? This is called square planar complexes. Now we are going to see optical isomer. Optical isomer. So what is optical isomer, right? The pair of two optical active complexes has a mirror image. So platinum two chloridoligons and two bidentate ethylene diamine, right? There's a mirror image with platinum, two chlorido, ethylene diamine, two ethylene diamine bidentate ligand, right? So actually, so what is the definition for optical isomer means? The complex is able to rotate the plane polarized light, the right side or left side. It rotates the plane polarized light, right side and or left side. Right side rotation means retro-rotatory, left side rotation levo-rotatory. This kind of compound are called as a optical active compounds or optical isomer. It makes the isomer. Here the pair of two isomer as a mirror image each other. That is called enantiomer. Enantiomers. Right? So today class we will see what is stereoisomer in the coordination compounds. So two types we will see: geometrical isomer and optical isomer. So geometrical isomer, what are the types? Cis and trans. In the octahedral complexes we have seen cis trans, facial and meridional isomer, right? So how are the structure will be, everything we have seen, right? And finally is ended with the optical isomer.